Hey everybody, it's Rick Uzzi. I'm here with Pete Olivia again. We're going to be talking today about OFDM and the TrueVision tab. We'll see you in just a minute. Hey, thanks for joining us again, Rick Uzzi. I'm here with Peter Olivia, our VP of Systems and Software. And last week we gave a rundown of OFDM and what it was. So we're talking about DOCSIS 3.1.
Yep.
And OFDM, let's see, orthogonal frequency division multiplexing. Did I get that right? Okay,
sure.
So OFDM. And I mentioned what we wanted to take a little bit of time this week just to show you what's in TrueVision, our DOCSIS Diagnostics tool for OFDM. And DOCSIS 3.1 is pretty, it's not new, but I think there's, especially on the smaller side, a lot of smaller, and when I say smaller, you could have 100,000 customers and not be doing DOCSIS 3.1 yet, right?
Yeah, I mean, there's some small operators that were pressured to go earlier that maybe had some of the big beast Google or AT&T U-verse in their backyard, and so they ended up going gigabit fast. So we had one that came right out of the gate.
Right.
So
yeah, but for others, it's some are thinking about doing it, some are trying to decide between fiber and DOCSIS 3.1 and what they're going to do as far as gigabit, and some they're like, we don't really care right now, because a lot of it is a marketing thing. Like Pete's saying, if you've got fiber operator right there in your backyard, then you're thinking about how you can compete on the marketing side.
Yeah,
right?
Move into your neighborhood, and you got to compete.
Yeah.
So DOCSIS 3.1's a good one.
Yep.
So go ahead.
So I'm going to take a quick look at it.
Sure.
All right.
Well, we talked last week about it's going to be really good to see that. So FYI, we didn't have a live 3.1 device in our lab that we had, so we actually took a screenshot. And you can show it to me. We took a screenshot of one of the devices that are out in the field, and we had talked about a couple things last week about kind of in places that what do you look for, what's important, if you can't do this, you can't do that, and so some things that you want to look at.
And I guess because this is a screenshot, we can move our mouse around that, but it's not going to show where the mouse is. So you're going to have to describe.
We'll just speak to what's on the
where
screen.
It is. Yeah.
So there's a couple different things that you can see. What's important in a 3.1 world. Really, what TrueVision is all about is what's important for me to see. You gave me an overview of 3.1. That's all great, but what do I look for? Some things that we talked about. Primarily, the first thing, if you can't talk on your PLC or your PLC, the physical layer, you're toast. There's just no OFDM anything. And if you look in the center of the screen, this would be where do you get to this? So you would navigate to your modem for the customer, and there will be an OFDM tab. You see it up at the top. It's actually highlighted. It's kind of yellowish orange right there. You click on if OFDM is capable on the device, that tab will be enabled. You can click on the tab if you're licensed for it, and it'll show you this information. It picks the first channel. You can actually have 2 channels right now. In the future, there'll be more. So if there's another channel, you can switch channels to drop down to pick which channel you want to look at.
Which OFDM channel?
Yeah, if you look right there on the left on the top, there's a drop down right there that has the OFDM channel name in it. I got a mouse over there, but no one will see the mouse move.
Yeah. I can point there, and
I
can't see my
point
finger.
at it, and nobody can. You can't see what he's pointing at. So, what are we looking for? As always, red, yellow, green. If it's red, bad. Yellow, warning. Green, usually good. So first thing that you want to look for, PLC. Am I getting any code word errors at all on my PLC?
And just a quick review in case you missed, and many of you may have missed last week. So the PLC, that's the physical link channel, correct? And that's where the modem looks for to get the physical characteristics of the plant, what the size of the channel, and
it's all the information. It's basically when the modem kind of ranges, it goes across, looks for those pilots that are in the
8 pilots around.
In the 6 megahertz channel. It's a small span in the middle, but there's kind of pilots on both sides guiding into the middle. And when it ranges, it goes and finds that. That's how it knows about everything about the OFDM channel. Basically, all the information about the OFDM channel. And if you can't talk to that, it's game over. So you don't ever want any code word errors on your PLC. So we picked one. We went out and found a device that actually had some that rang up. So this one is got one code word error that happened on the PLC. That would be a problem. You don't want to see that at all. If you can't lock onto the PLC, it's game over. So that's one thing. The other one is your next code word pointer, which is kind of tells the device, here's where your code words are going to be. Here's the profile that you're going to have on those code words. So basically, it knows what quantum modulation to use and where and what time to go get it. That's what the next code word pointer is, and it tells it where. If it has any problems talking to that, obviously you can't. Well, I don't know where to go to get my code words for me. So if you have any code word errors there, you're going to have problems as well. So that's also on there. Here we got a couple code word errors on the NCP. That's why we picked this guy, because he had some problems.
Right. Okay.
Normally you'll see zeros there, and that's base level. If you can't get PLC and NCP, you got bigger problems. It's not so much degradation; it's you just can't even use the channel.
Now, we were saying that last week. When you can put, as far as the DOCSIS specs, you can put that PLC wherever you want it. It just needs to be in a 6 megahertz area where you're dead center in that, and then it puts the pilots around there to find it. But you don't want to put that anywhere where you have any kind of noise that you want to put that in the cleanest part of your plant, and this is why.
It just needs to be in a good part where you're not going to get any interference or ingress noise or anything like that. The next thing you would look at beyond that is your profiles, individual profiles. I have different quantum order modulations. The 0 profile, the A profile, is what all devices need to lock onto. Same thing in the middle of the screen. We have the PLC, the NCP, and then to the right of that you have your correctables and uncorrectables. So in this case, we're actually seeing correctable errors in some cases. Profile 0 is kind of where all the messaging happens. The device is always going to lock onto that. That's how it kind of communicates back and forth with the CMTS. So you're always going to have some kind of traffic on there, but mostly messaging. That's profile 0. Every modem needs a lock onto that. And you can see at the bottom, there's actually 2 channels that it has locked on at one point, 0 and 3, and under your bandwidth. That's why they're listed there. You could uncheck those and pick just 0 or just 3 or whatever you want to look at. It's the bandwidth usage of that profile on this device over time. So you can definitely see locked onto 0, right? Because the 0 is down there, it's in blue. Okay. We're not seeing any correctable code word errors, which is good. So at a base minimum, this device, even though we had a couple code word errors in there, it's able to lock on and work. As you go up, you can see the different profiles. This one happens to be, as it went up, this is what most operators do. As you go up in the profiles that are there, modem can have 4 profiles right now. You can have up to 16 in the CMTS, but the modem will get assigned 4. That's what it can have. And in this case, the order quantum modulations are going up. So we're getting higher modulation orders, more speed, more throughput on that same OFDM channel for this device. So the modem is actually locked onto 3. You can see at the bottom, you see bandwidth over time on channel and on profile 3. And he's actually using that because he can lock onto it. That's the one that has the highest order modulation. Even though he's doing a ton of correctables, it's almost like 90-something% correctables here, he's able to still function. Not great, but it locked onto that profile and is able to use it. But you can see he did have some correctable code words on 1 and 2. So you can see even wherever that is laid out in the plant, it's still getting some error correction happening on those code words that are going across those profiles. And these are things to look for. Obviously, uncorrectables we're not getting any, which is great. That's what you're kind of looking for, is you don't want that.
What are we looking up at the top there? That's the downstream received power. So
so
over 20, and we're looking at 24 hours on that as well?
No. What you're looking at there is, so that's the whole span of the OFDM channel.
Okay.
All right. In reality, your power is spread across, 8,000, 4,000, depends on how wide your channel is, little subcarriers.
Right.
Well, what they did in Cable Labs was everybody knows 6 megahertz. So they made a metric that quantifies. You're looking at how much power there is over a span of frequencies. So it's relative to how wide you are. So if I show everything in subcarrier, your power levels are going to be different than if I'm over 6 megahertz. So to make it more like relatable for people that are used to seeing 6 megahertz, they gave a metric that we could pull that are 6 megahertz wide. So what this metric does is it takes the full span of the OFDM channel and breaks it up into a virtual 6 megahertz so that you can compare what you would normally expect at a 6 megahertz level across the OFDM channel. It's not really relevant completely to each individual subcarrier, but it gives you kind of a high-level view. That's what we're trying to do on this page, is give you a high-level overview of am I high on power, am I low on power? And these will go red, yellow, and green. If you're too high, you'll see it high. If it's too low, it actually will go down. And what's funny is when you see it, because it's under 0, it looks like why am I inverted?
The bar graph goes below.
Yeah. It looks kind of inverted, and everybody's like, what's going on? Because you'll have a line across the top, and it looks like I've inverted, like I've inverted the colors. But that's because it's negative. You're just looking for, am I having any power problems? Am I have big suck outs or roll offs? And you can see here, the front side of the spectrum is lower than the tail end. And it might be something to look at, right? I mean, you've got kind of a long-term tilt over the entire OFDM spectrum. So you're looking at the whole OFDM channel broken into 6 megahertz spaces. If any one of those is red, yellow, green, you got a problem in that area for some reason. And if you look at the top of that, you see that blue section? That's actually where the PLC is.
Okay.
It's not necessarily in complete line with one of those 6 megahertz, but that's the center. It centers on the frequency. That's 6 megahertz wide. The PLC is right there. And over to the left, we actually put the PLC frequency in there. I can't read it if you can see it on the
it looks like PLC frequency is 350.8 megahertz.
Yeah, so it's right where the blue is, right? That's what ends up happening.
The PLC power.
So these are things you want to look for. Do I have any power? Do I have any suck outs in my power? Do I have it screaming at anyone? Do I see it dropping off? You can see it when it gets to the edge of the OFDM channel, it starts tailing off. You're getting some roll off there at the end.
It looks like on this one there's 21 or 2754 active subcarriers. Yeah,
on the left there's a whole bunch of information. You've got what profiles were assigned to this device. 255 is an NCP, by the way. 255 is an NCP. Everybody's going to get that. But this one's 0, 1, 2, and 3, right? So you could have up to 16, 0 through 15. Most folks will just do a couple profiles because one can only get 4. Most of them only put in 4. But those are the ones that are actually assigned. The channel ID, if that's relevant to you, you can see what it is. You can see the frequency. And the next couple are, you can see how much power is on the actual PLC channel, right? The actual power itself on the PLC is there. And is there any partial service? We'll show you if there's any partial service going on the device.
Looks like there's 36 pilots. Again, the pilots that we talked about last week are there to. You've got continuous pilots that are spread out pretty evenly across the channel that are there to provide some checks, I guess, on frequencies, keep the subcarriers in line because the subcarriers need to be.
A lot of this is some informational things that you may want to know. How big is my span? How many subcarriers? How wide is it? Where's the start and end of my OFDM channel? It gives you an idea. It's just informational that we put in there. What's really relevant for metrics is the bottom. They're green. See, they're green. You have
receive MER.
Yeah, the receive MER.
So
what that is it's the average mean receive MER for every subcarrier across the entire span of the OFDM. So one of the things that Cable Labs came up with was this idea of what's related to 6 megahertz. In a 6 megahertz world, when you have a single QAM, your MER is only over 6 megahertz. That matters, right? I mean, that's kind of relevant. Your MER SNR over that 6 megahertz span is relevant. In an OFDM channel, you might be, what was it, 192 megahertz.
Right. Yeah.
So average MER over 192 megahertz, that's like your whole plant. Like, what's my average MER across the whole plant? That alone doesn't give you a lot of info.
Yeah.
I mean, you want it to be at a good number, but what's the bell curve look like? So anyone that's ever looked at statistics, you can tell by the crinkle in the forehead from the pain taking the class. What Cable Labs did was they said, hey, we'll give you 2 metrics related to that. So we're giving you the average MER, and then on a bell curve, how many standard deviations off of the norm is there? Anything above 2 would be, you might have, your normal bell curve, 2 standard deviations is your 99.5%.
Sure.
I'm really digging.
No.
I can't remember.
Nobody knows math. It's okay. You can say whatever you want.
So what they do is they give you a metric where, you want your average MER good, which is green, but you also want it to be laid out in such a way that it's a bell curve. So if you get anything that's more than 2 standard deviations off, you're really not. It's not
in the center part of the bell.
While your average is 44, it's flatter. It's not a bell. It's more. It could be tilted a little. It could be flattened. So what you're looking for is good MER, good average MER, which everyone probably knows. What's the number on there? Can you see it?
Looks like it's 0.95 for standard deviation. Oh, the MER is 40.11.
So 40.11, that's really good. That's really good signal for OFDM channel. And it's 0.9 standard deviation. So you want to be less than 2. We're under 1.
Just under 1.
So you got a really steep, you're like here instead of a bell, which is kind of out, you're very narrow and steep. So most, if not almost all your signal is in, in that nice little sweet spot. And one more metric we have in there is the receive MER
threshold
at 2%. So they take all the MER of all the subcarriers and they put them in numerical order, and they go all the way down and go down to the 2% mark and say, what is that? So 98% of your signal's above that. And what number do we get there?
We've got it looks like 38.25.
So 98% of all your MERs for all your subcarriers are 38.5. That's pretty good. So you have 2% that are below that. That's really good. So those are things to look for, and they'll turn red, yellow, green based on if you get too spread out. If if your 2% threshold is like low, like 30, bad. If your average MER is low, any of those things. So there's just a lot of data to look at, thousands of data points. This is a great way to roll it up. Like I said, green's good. Yellow, start worrying about red, bad. So you want good MER. You want a low number for your standard deviation, under 2. Here we're under 1, which is great. And your floor, you're basically 2% floor. 98% of all my MERs in sorted numerical order are above that number, which is good. That's really good, right? So these are things that you can look at. And then bandwidth-wise, you can see, what are they going up to on that bandwidth? What they got up to? 200. Yeah, 200. Yeah. This customer probably has a 200 meg package. So, you can get a lot more with OFDM, especially on I think this one's like 192 megahertz wide channel. It's pretty wide.
That might be smaller because it's active subcarriers.
So you can see the upper and lower frequencies subtract, and that's roughly where it is. But you can get a lot out of that. So this one, you can see the subscriber actually got up to 200 megahertz. So you can see over time what kind of throughput they're getting. One other thing, are they switching between profiles? So even though they have a lot of correctables, they've been able to lock on and use that consistently. They've been consistently on profile 3.
And I did notice when I was actually looking at this live, we're looking at a screenshot now, when I looked at it live, I unselected the pink color, then you could see the blue color pop up because you could see what usage was there. And obviously it was lower because it looks like a flat line right now.
It's basically the messaging channel. They could lock onto 0 and use that, but that probably is 256 QAM. Like I said, most folks, when they're doing 0, 1, 2, 3, they're 256, 512, 1020, 256, 512, or maybe 1024, 2040, 4096. Depends on what they can get away with in their plant. And then you can come in here and validate what they're locking it onto. You might see them flip-flopping around between profiles over time if they're having problems. And if you're seeing any uncorrectables, you got that problem. That also tells you, hey, wherever I've designated space, maybe profile 3, we need to go look and see where we've allocated spectrum for that in the subcarriers and see, are we getting ingress noise there? What's going on?
Especially, like you're saying, with where the PLC is located?
Well, I'm just saying on the profiles. The profile itself, when you put profile 3 in there, you designate where you want to put those. You might want to go look and see where that's landing because we're getting a lot of uncorrectables. So it might just be that we're pushing to the edge. I mean, we look like we're getting good SNR. The power levels look pretty good. We're just pushing that as much as you can go. We're really taking it to the edge. But that's great because that's what you want. You want to get the most with what you've got in your plant. But at a high level, that's what you're looking for. I can't think of anything else but that's it, right? I mean,
that's it. Yeah, it's good info.
Yeah.
So, all right. So as you can see here, if you've got TrueVision now and you're not on DOCSIS 3.1, this is something that you would have to look forward to as far as some diagnostics, and we'll be over time adding to this various things that we'll be looking at.
Yeah, they're going to be adding more features and functionality in the 3.1 world
as we go. So that's it. So if you like this video, give us a thumbs up, and I'll be back next week. I I don't have a topic yet, so we'll be coming up with a topic. It won't be with Pete, I don't think.
I've been set free.
You've been set free for a little bit. I'll have you back soon, though, because there's other things that we need
do we
to
have
talk
anything in the chat? I mean, I see the chat window, but there's
No, I don't see anything. I don't think we have any questions. So,
all right, so I've escaped again. Huh?
Yes, you have.
I think you keep the broken chat window. I don't have to answer questions anymore.
Yeah, we did get a question after the broadcast last week, which we answered, so we were handling that. So. All right, well, again, I'll see you next week for Tech Tuesday, 3 o'clock. We'll see you then. Thanks a lot. Bye-bye.